Thank you for joining Link Labs for a presentation of the AirFinder SuperTag, the new gold standard in indoor and outdoor asset tracking. If you're on the East Coast like we are, we hope you're staying warm and safe indoors and you weren't hit too badly with the snowstorm that came through yesterday. A couple housekeeping items as we get started. We'd love to answer your questions. You can use the questions or the chat features on the GoToWebinar control panel, and we'll have a Q&A session at the end and answer as many questions as we can. We are recording today's webinar so that you can have it available as a resource. We'll follow up with you in about 24 hours, and we'll also send you a brief survey and would love to get your feedback about today's seminar. I'm excited to introduce Glenn Schatz as our webinar speaker today. Glenn Schatz is Vice President of Strategic Partnerships at Link Labs. He's worked here for 6 years in a number of different roles, from product management to operations and business development. Glenn graduated from the U.S. Naval Academy, where he eventually went back to teach energy policy as a military officer and civilian professor. Prior to his return to the Naval Academy, he was a nuclear engineer qualified submarine officer stationed in Virginia on a guided missile submarine, and he received his master's degree in national security policy from Georgetown University. Glenn was born in Taipei, Taiwan. He grew up in Tucson, Arizona, and he currently lives in Baltimore, Maryland. Thank you, Glenn, for presenting this information to us today.
Thanks, Jennifer. Happy to be here, and thank you everyone for joining. We had a really great response. I think we had over 1,000 registrants, so hopefully a number of you were able to join us live. And I'm glad to be able to share a little bit about how we see the state of asset tracking. I'm going to spend a little bit of time making a self-serving plug for Link Labs and what we do, but I do want to focus the majority of our time today on just an overview of the landscape, the way that we think about the problems of asset tracking, both indoor and outdoor, and then to discuss some of the strategies and technologies that we use to solve some of these problems. And then I'll try to leave about 10 to 15 minutes for questions and answers, but throughout the presentation, if questions come up, please chat them in the GoToMeeting chat bar, and we'll try to get to them. And if we don't, we can always reach out afterwards if you leave your email address and phone number. So today we're going to go through current GPS trackers and how they typically work, what's state of the art in asset tracking. We're going to go through some specific use cases where we've found a lot of value delivered through pervasive tracking. And I think a lot of these types of webinars don't get into the nitty-gritty about costs, but I'm going to do that in this webinar because I find that understanding the cost of things is really what drives IoT adoption, and it doesn't help to walk away from this webinar without understanding some of the general costs that you'll be facing to implement a solution like this. So briefly about Link Labs, we are about 7 years old. We were founded by a group of research engineers from the Johns Hopkins Applied Physics Lab who were mostly working on low power asset tracking and monitoring for US government types of applications. Our founder came from APL, and at Link Labs, we really built a company around low power wireless initially. So I'll go through some of the innovations that we led on the next slide, but we really care a lot about cost and power. We feel like adoption of the Internet of Things and IoT devices really comes down in most cases to cost. And there are a lot of elements of cost, and I'll get into that, but one of the big drivers of cost is the actual physical hardware cost. Another is connectivity cost. And then of course there's the replacement cycles, and so battery is really important to us. We are also constantly innovating. We are technology agnostic, so we try to focus on things that can deliver value to our customers regardless of where they come from. Just a little bit of background. So we started off as a wireless module and gateway company. We had the first FCC certified LoRa devices in the United States, and we also had the first LTE-M1 carrier certified devices in the US. Over time, we decided that moving up in the value chain and up in the stack was beneficial to our customers because they didn't have to go through these long design cycles. And so we started doing things like Bluetooth-based asset tracking, Bluetooth and ultrasound hybrid asset tracking. And then in the future, we're going to be doing a lot of things around ranging and certain things that are now available with the new Bluetooth 5 specs that are out there. And then, of course, over time, we can bring other things in like machine vision and other edge type of technologies to enhance our offering. So one of the challenges around the Internet of Things is that oftentimes proofs of concept are pretty straightforward. You can get a Raspberry Pi, you can get a SIM from development SIM from an MVNO. You can put those together. You might be able to do some dev board to dev board type of communication. So everything seems pretty straightforward when you have an innovation lab. But what we found is every time you increase the number of devices by an order of magnitude, so when you go from 1 to 10 or 10 to 100 or 100 to 1,000 and so on, things can get a lot more complicated. And when you're going from even a 1,000 unit POC to a 10,000 or 100,000 unit deployment, things can get very complicated and you end up running into unforeseen costs and complexities, whether that's around provisioning or configuration. It could be around lead times on parts. It could be around the logistics of getting your devices mounted and installed into the end customer. It could be around negotiating carrier contracts globally. So there's a lot of different elements that make deploying an IoT application at scale very challenging. And we've tried to put all of those together and be a one-stop shop for all of these items. So, there's an area in all proofs of concept between proof of concept and deployment that we call and others call the valley of death. And one of the things that we try to do is get you through the valley of death as painlessly as possible. And while we do offer the full stack solution to make it easy if your business is not IoT, we also work very well with systems integrators who can plug into our system in various places. And so we have both models, but what we found is being able to offer the full stack solution at scale, it makes it easier for us to know where problems are hiding as you get up to scale, which is not necessarily the case in a lot of other hardware vendors or platform providers. So I want to spend a few moments and talk about a technology that we as an industry call GPS, but everyone else calls GPS also. And I want to just level set. There are a lot of different things that people mean when they say GPS. Sometimes they just mean location, but I want to make sure we're talking very specifically here because I'm going to get into some of the nuance throughout this presentation. So GPS as a synonym for location can refer to a broad array of geolocation technologies, but today, when I refer to GPS, I'm going to be talking very specifically about the Global Positioning System, which was a set of satellites managed and launched by the US government. And there are other constellations of satellites out there, like GLONASS, Baidu, Galileo, and then, but for the most part, all GPS chips that you would buy on the market today can support multiple constellations. And so when I say GPS, I mean satellite-based location. There are other ways to aid in location, and I'll talk about those today. So when you talk about GPS on your cell phone, for example, it's really taking advantage of a number of different technologies, from those GPS satellites to Wi-Fi positioning, to cellular positioning, to inertial positioning, to even now, I just saw Google announced last week that they are starting to use 2 and 3D imagery to assist GPS in urban canyons, and I'll talk briefly about that in a second. So when I talk about GPS specifically in this presentation, it will be around the satellite-based positioning. So, oftentimes GPS by itself is not enough, which is why we and other providers use different types of location technologies. So when you're indoors, one of the things that is important for GPS is a line of sight or a direct path to the GPS constellation of satellites. And if you're in a building or you're being blocked or shaded by large buildings, you might not get that line of sight. And so your GPS fix can be way off, or you can not even get a fix if your chipset can't resolve that location. Additionally, in challenging RF environments, so if there's areas with a lot of metal or a lot of interference, GPS satellites may not perform well. And then also, one of the things that is really important to us is that because GPS can take a while to get a fix, anywhere up to 5 minutes, depending on how bad the situation is near you, around interference or indoors or multipath, it can really drain a battery. And I'll talk very specifically about how much it can drain a battery in a few slides. So while GPS is great if you're driving, if you're near a window, if you're in a residential building where you can get penetration through drywall, in commercial facilities and manufacturing facilities, you may have issues, and then especially in a lot of the environments we're in, where you might be in a manufacturing facility with heavy equipment, with metal machinery, metal racking, metal crates and totes. GPS is almost your yield on GPS can be very low. Now, there are some applications where we see GPS fixes succeeding only about 10% of the time. And so we and other providers have looked at ways to augment GPS to be able to provide location when you're in places where GPS struggles. And I'll go through some of that in a minute. So this is the brief sales pitch time. We have a couple devices that can take you where GPS can't. They utilize GPS, but they also utilize a number of other technologies, such as Wi-Fi positioning, cellular positioning, Pulte, and Bluetooth for microlocation, and I'll go through all those in a moment. We blend these different technologies to both take advantage of the different and wide scope of location technologies, but also to make these devices last as long as possible. So rather than having to charge your phone every day, our devices can last, the large device that you see on the left here can last 5 years or more. And then the smaller device can typically last a couple of years, depending on the use case. So these are not, keychain size devices, but they're not huge either, and they typically work well with most of the applications and use cases that we see. And then if these two devices don't make sense, we have a really good ODM partner for our SuperTags, Circom. And they can help us innovate very quickly with different forms and sizes, different battery configurations. And so there are already things like keychain size trackers, as well as trackers that are designed to fit inside of pallets, for example, that we have proofs of concept with. And so if you have a specific need, either on a battery size or type or form factor, we can iterate on our existing designs very quickly to get you what you need. So I'm going to spend a moment on this slide just to go through the different technologies that we use. But these aren't necessarily technologies that only we use. They're technologies that are pervasive in the industry. But I think it's important to understand the difference in what they bring and what their accuracy is, and what their power performance is. And so when I go through this, I'm going to be talking about what's called a fix. And so a fix is really just the ability to resolve a location. And so, you could think of it synonymously with latitude and longitude, to basically put a dot on a map. Those dots on the map typically will come with some sort of area of uncertainty or accuracy figure around it. So we would call that, a bubble or an AOU around that fix. And as I go through the list, it kind of goes from most accurate to from least accurate to most accurate. But there's some nuance with each accuracy, because there's a thing that that's important, which is, can you actually get the fix where you are? So Cell ID is a pretty pervasive location technology. Basically what you're doing is you're using either open or private databases of cell towers, and it's provided by people like Google, Mozilla, Here, Esri, Combane, Skyhook. There's a number of different providers that have millions of samples of cell tower information to be able to provide a lat and a longe when you do an API lookup. But typically the accuracy isn't great for those. Anywhere between half mile and a couple of miles, depending on the density of cell towers. So in an urban environment, you might actually get better performance because there's a higher density of cell towers. If you're in a rural environment and the closest cell tower is a couple miles away, then you're kind of limited to the accuracy of that single cell tower. There's a way to improve that. So one of our partners, Pulte, uses the cell towers much like a constellation of GPS satellites. So they have not only the database of cell towers, but they are also able to get certain RF characteristics off of those transmissions at the chip. Use that to then further refine the fix and get you down to anywhere between 100 and 500 feet or better in certain circumstances. And so one of the nice things about both cell tower positioning as well as Pulte is that if you can get a cellular signal out, which is the only way you're going to get data back in most cases from a device, you'll get a fix. And so your yields are going to be nearly 100%. In some places you won't be able to get any data out from the device, but in that case it doesn't matter because you can't communicate it anyway. And so when you're looking if you need to know where your device is at all times, but accuracy isn't necessarily important, or the 100-foot accuracy or building level accuracy is enough, using cell tower Pulte is a great answer for you. The nice part is they're both very low power as well. Wi-Fi lookup is similar to Cell ID. It involves both open and closed databases of what's called a BSSID or base station SSID. So each one of your Wi-Fi access points that you have has a unique identifier, and Google and Apple and others, as they're doing positioning with the mobile devices, collect information about BSSIDs and send that up to help resolve a location. And because the range of Wi-Fi access points is much shorter than cell towers, you can usually get a pretty good resolution anywhere between 25 and 100 feet if you're able to look at multiple Wi-Fi BSSIDs and pass that up again to these databases that have hundreds of millions of samples. The challenge with that is if you have a location where there's no Wi-Fi base station you can pull from, like on a highway or in a very remote area, or you're in a place where there may be only 1 or 2 Wi-Fi APs and they're not in the database, then you might have problems resolving a Wi-Fi location scan. And so typically, if you were to take all the fixes that are out there, about 30% of the world can be covered by Wi-Fi lookups, but in certain areas it could be much closer to 90 or 100%, especially like in urban areas. There is some risk around a bad database there, but for the most part, Wi-Fi can be a good low power way to get location. Then there's actual GPS, and again, this is very specific to satellite-based location. This is the most accurate way of determining location when you can get it. So again, it's kind of 10 to 50 foot accuracy, depending on what else is around and how much resolution you have to the constellation of satellites. The challenge with the GPS, it is the most power hungry of all these location technologies. And then also, again, if you're indoors or in a container box or a truck, you might not actually get a fix. And so it's important to have alternatives if you don't have GPS. And then one of the other things that is unique to Link Labs is that we offer an indoor positioning system based on Bluetooth. And unlike most approaches, our devices are actually listening for Bluetooth beacons. And so you can install a very light infrastructure, and like a phone might listen to Bluetooth beacons, these low power devices are scanning as well. And if you have a location beacon as a reference, you can get very granular down to the workstation level with indoor location. And so we find that not every one of our customers needs this, but it's a nice way of future-proofing the application. So if you start off only needing warehouse level accuracy, you can use any one of our technologies to do that. But within the warehouse, if you now decide, hey, I need to know, is it in shipping or receiving? Is it at the maintenance part of the facility, or is it at the docking station? You can install a handful of beacons throughout the facility and get yourself down to that sub 10 foot level of accuracy. So as I mentioned, battery performance is very important to us, and we like to say that you should only use the battery you need to get the accuracy and the and the insight you want. And so being able to actively adjust how frequently your tag is both locating as well as checking in with heartbeats, how frequently it's checking to see if there are firmware or configuration changes, and then specifically also around which location technologies you want to use for your application. These are all things that you can configure remotely. We have some profiles based on our experience that are good for different use cases. And so we could start you off with something that we think might work for you. But after about a month of use, we typically like to evaluate your use case in your environment and tell you, hey, you have GPS as your first choice, but you're really only getting a GPS fixed 5% of the time. You may want to turn that off if you know you're not going to get it. Or you may want to use GPS as a backup to Wi-Fi. For some reason, you care about that when you're on the highway where there might not be a GPS, a Wi-Fi BSID that you can use. We also have an accelerometer on all our tags that can be used or not used. It can be configured for the use case. And then one of the things that I don't mention in this slide, but I'll talk about, is a feature that we call last until. And so that's specifically for use cases where you can live with not necessarily checking in as frequently, but you need to have your tag live for 2 years or 4 years or 5 years. And so your tag will check in however you configure it, but then once it realizes that it's using too much battery, it might scale that back to maybe checking in only once every 2 days or once every 3 days. So that gives you some ability to have comfort if you have a specific deployment cycle or a product life cycle where you need your tag to live out in the field and you're willing to sacrifice a little bit of insight into where it is, or it's a primarily static asset, but you want your tag to last a certain period of time. That's a feature that we can enable. Why is this important? Well, as you can see in this slide, we've tried to benchmark what a weak GPS signal would look like against these other technologies. And this includes both the GPS scan and the fix, as well as the cellular transmission to get that fix to the cloud. So in this particular example, the weak GPS means that it's failing a GPS scan, so it's taking about 3 minutes with our current configuration. Strong GPS is assuming a fix less than about 20 seconds, as good as 10 seconds. And then Pulte, Wi-Fi, and Cell ID, really the majority of the power used in those cases is to send the data using cellular, using Cat-M1. The other thing that I don't have here because it's too small to see is if you're in one of our indoor AirFinder networks using just Bluetooth for communication, the actual cost from a battery standpoint of transmission and location is negligible. Your primary driver there on battery life is the sleep current or the quiescence current of the device, which will apply in all of these cases. So we don't list it up there. The other thing worth noting is this is specific to LTE-M. NB-IoT would look a little bit like this as well, maybe with a little bit better power performance. But if you had a 2G or 3G tracker, it can be multiple times this amount of battery use. And so one of the questions we often get a lot is, hey, do you do 2G fallback or 3G fallback on your devices? And we don't right now. It doesn't mean we can't. The devices we use have that capability, but we find that having to count on falling back to an older cellular technology creates too much variability in the battery use and consumption. So it's something that we've seen in a lot of RFPs, and we've seen a lot of people ask for. But typically, when push comes to shove, we're able to descope that from the projects because there are some areas where that may be absolutely required if you're still operating off very old infrastructure in certain parts of the developing world. But over time, the need for that fallback is going to go away. And in most of the cases we work with, it's much more important to get the advertised battery life than it is to fall back every once in a while when you can't get a good LTE or 5G fix. So one of the things that I briefly touched on was this concept of indoor location using our Bluetooth-based system. Typically, in the past, when you've had an indoor tracker, it only worked indoors. And when you've had an outdoor tracker, it only worked outdoors. Or it would use one of these other technologies like Cell ID or Wi-Fi when it was indoors. But you were not able to get down to this level of granularity. And then also one of the challenges in some areas, especially in places like hospitals and hotels and some manufacturing facilities, is once you get too deep inside, you actually don't have any cell coverage at all to get the data out. So what we've tried to do is create a hybrid solution that allows you to do fine-grained indoor location at a low cost, in addition to the outdoor location, to be able to take you seamlessly from outdoors to indoors, to give you long battery life, whether you're tracking indoors or outdoors, and also to fill in gaps where there are cellular gaps, which we find again in a lot of buildings. One of the applications that I'm going to point to here is something that we've done for Marriott. It's an indoor location technology, but one of the challenges we have in a lot of hotels is, as you know, you lose cell coverage in a lot of areas, and so anything that's reliant on having pervasive cell coverage, what was a non-starter for them. And so we were able to install our AirFinder system, which is a combination of Bluetooth, LoRa, and cellular, to install housekeeper alert systems that have coverage in all the rooms and can, we did a hybrid system with both Bluetooth and ultrasound to be able to give people room level accuracy when housekeepers felt threatened or were being assaulted. They push a button and call security. And we found that this hybrid approach is really important. There are some places like resorts and things where there's not a lot of density and the housekeepers might be outside, where a direct to cellular connection might be the right answer. But we like to have options, and so we find that giving a flexible indoor-outdoor option for our different use cases is really important. And then this is just an example of how that micro-location indoors works. We have a location beacon. Those location beacons are deployed and provisioned, so they're it'll tell you room 302 or 303 or aisle 2, row 5, or something like that. And when one of our super tags or any of our Bluetooth tags hears that location beacon, it then reports its location based on some algorithms that live on the tag. So one of the nice things about this type of micro-location versus the approach where the tag is just beaconing is it doesn't really clutter the airways with a lot of Bluetooth traffic. And it's very scalable. So if you had 100 tags go through a choke point, you'd actually be able to get the signal through because you wouldn't be sending thousands of beacons every few seconds. It would really only beacon, the location beacons would beacon at a fixed rate, the tags would scan when they moved, and then they would report the location they were closest to. So the next few slides are just some examples of our user interface and things that typically people ask to see. So this slide is a trip report. As you can see, I think this was our CEO that drove cross country recently. So we tracked him. I don't know if he knew or not that we were tracking him, but we tracked him anyway across the country. And we saw some gaps in coverage in certain areas, but as you can see, for the most part, we got pretty good location throughout the country. This is an example of I believe this is a warehouse. And you can see each one of the little numbers corresponds with a number of tags at that station. And so this is what you might expect to see in our user interface if you were indoors. And then of course, people love to see the indoor-outdoor transition. And this, quite frankly, is somewhat of a more of a sales pitch than something that people use every day. But to be able to look at your assets on a map and then be able to see, hey, I have 1,000 things at my warehouse in Delaware. I'm going to zoom into Delaware and then start looking at which aisle and row or which workstation my assets are is a neat thing for maybe a supervisor to look at or a facilities manager. So this slide tries to summarize the way that we look at asset tracking. So it's an end-to-end thing, right? So there are lots of good indoor technologies for asset tracking, everything from ultra-wideband to traditional beaconing to passive RFID. There's a lot of things that you can track, frankly, outdoors. There's 2G and 3G GPS trackers that you can buy on Amazon. There are LTE trackers coming out. There's a phone app. There's Bluetooth tags that you can pair with a phone, right? But in environments where you're going to be over the road or in third-party sites, some with good cell coverage, some with bad cell coverage, some with Wi-Fi BSID, some without, some with GPS line of sight, some without. You have to have a technology that works everywhere. And so each arrow here represents a different hop between a different organization. So it can get really complicated at scale. And if you want visibility throughout this entire value chain, you need to be able to have a technology that works everywhere. It's possible to take these different technologies that are out there and integrate them yourselves. We have, again, systems integrator partners who do this every day. But what we found is the more you can put together, the more you have what we used to call in the military a single belly button to push or to poke when you want to know where something is. The easier it is for you to do your job, which typically is in asset tracking. Your job is typically to get your customers' items or figure out where your leased assets are and get them back, or figure out how to charge people for things that they have. So that's your job. Our job is to help you find it. So I want to spend the next few minutes talking about some specific use cases, and then I'll stop and open it up for questions. So the three, I mean, there are many use cases, right? So I think we have a list of about 30 different things that when we send our sales team out, they can talk about. But the three that I want to focus on today are equipment utilization, loss prevention, and compliance. For equipment utilization, think about things like returnable assets, racks, pallets, crates, container boxes, leased equipment, things that you have, you give out to other people and you want back. And in some cases, you might give it out to another warehouse that's within your company. You might give it out to one of your distributors. You might give it to a 3PL. In some cases, the distributor or 3PL might send it directly back to you. In other cases, they may send it downstream to their customers. And then in some cases, you may want them to send it back to you, and they may send it to their customers without telling you. And so there's a lot of benefits for equipment utilization in understanding where your things are. So for things like returnable assets, like pallets and racks, typically they cost you money to make and manufacture, anywhere from hundreds of dollars to thousands of dollars, depending on how customized it is. You are lending them as a service to your customer to allow them to take possession of your thing, but typically you want it back. And what we've seen is a lot of people have to create way more of these than the amount of goods they're shipping to their end customers, because customers like to hang on to them for whatever reason. Also, things like leasing and rental equipment, depending on what the business model is, you might want to see or know if your customer is actually using something you've rented them, because you may be able to charge them differently if they're a high utilization customer or a low utilization customer. You may want to know where the customer is using it so you can reposition some of your inventory to provide just-in-time surge capacity. To say it's a construction company that is renting JLG lifts, and they typically only need 5 any given day, but for some reason you now see, hey, for some reason a bunch of JLGs are being repositioned to Milwaukee. Why is that? Well, I don't know, but I probably should move some from St. Louis, up to Chicago, and maybe get them over to Milwaukee if for some reason people are using more of them. So it's things like that. It's more insight into the things that you make money on, or you have a cost burden on. Another big one is loss prevention. And so this can apply to some of those same items. Again, not necessarily theft, but people using your equipment in ways that you hadn't anticipated it or wanted them to. And in some cases, it is theft. So for high value items, for expensive audio visual equipment that's being rented, in some cases you can charge your end customer. But if you don't have a really strong chain of custody, there may be a lot of finger pointing and he said, she said about where assets got lost. And this is especially true around things that customers don't value necessarily, like the pallets and racks that they look at as the way that a consumer might look at a grocery bag, but there's a real cost to you, because if they don't send it back to you, you need to make more of them, and that comes out of your cost center. So I think it's really important to think of loss prevention not only as theft, but as either misappropriation or misuse of your stuff, and that can apply a lot of different ways. And then the last one I want to talk about is compliance. So this is something that a lot of people on this call might not be that familiar with, because usually it's like the CFO or someone from your audit group that might care about this, but a lot of capital assets are required to be inventoried, and if you don't do that correctly, you can either run astray of the tax man or of the auditors or all of the above. And so if you have a capital asset like heavy machinery or specialized tools or things that are, you know, expensive that you want to keep track of, and you have one facility in California and one in Nevada, for example, you might think that someone shipped that specialized test equipment from your California facility to your Nevada facility, but in most cases you don't necessarily have a good accounting of it, and you sort of have to rely on either you know, packing slips or some sort of inventory control that you might have. But if you think about the folks that are shifting these things around, sometimes they might be research engineers or operations managers who their core business is getting the stuff to where it needs to go, but not necessarily keeping track of it once it gets there. And so this will help you know, the CFO shop keep track of these assets and make sure that you can account for them in a very controlled way, and you know where all of your equipment is. And while that may not matter to you, it matters to the people who are cutting your paychecks and giving you budget. So if you can figure out a way to save them money, I've always found that to be a good thing. So I'm leaving some time for Q&A. So I want to go through a couple more slides, and then I will open it up for Q&A. So let's talk about costs. And so I'm going to tell you in a second how much our stuff costs, but a lot of you have pieces of the stack and are kind of curious about other pieces of it. And as I mentioned at the beginning, I find that transparency here tends to be the best way to have good conversations as opposed to trying to hide some of these costs. And so when you look at the cost of an IoT device, especially an asset tracking device, there are a number of things you have to consider. Hardware, connectivity, and that's either cellular or LPWAN. A platform fee. It's not free to manage these devices, or if it is free, it's because someone is making money on you some other way, whether through connectivity, hardware, or some other element. Installation, which can be in some cases as easy as putting a tracker inside a box. In other cases, might involve a custom mounting accessory, and then replacement and end of life. So this is where thinking about things like how long a device lives. How do you replace the batteries? If you need to pull a device off of a thing and then replace the battery, how much does it cost? You know, do I need to replace the device because the technology is outdated because I used 3G and all of a sudden, you know, the 3G network's getting turned off, which is a very real thing that's happening soon. And I have another webinar that if you have questions about that, I can point you to. So hardware for these tracking devices, you know, you'll see typically anywhere between around $40 or $50 on the low end for the cheapest 2G, 3G trackers, all the way up to hundreds of dollars for the most sophisticated trackers that are out there. So that's kind of the baseline of what you have to think about for hardware. And as I mentioned, the only 2G, 3G trackers that are out there, you know, are typically being used in developing countries, and then they're being end of lifed elsewhere. Connectivity is important. I'm going to talk about connectivity and platform fees as a bundle here because a lot of times people are putting those together. And for IoT devices, connectivity can be a little bit cheaper. So, you know, for your cell phone plan, you may pay around $10 per gigabyte per month. But if you have a device that's only using a megabyte of data or 100 kilobytes of data per month, that doesn't really fit into those same data plans. And so you can expect to pay, you know, a couple bucks a month for connectivity, less if you have volume. And then for platform, typically it's around that same amount, anywhere from tens of cents to dollars. And so typically when I look at connectivity and platform bundles, it's usually in the sort of $1 to tens of dollars ranges. So think dollars to tens of dollars, again, depending on what the company's offering you and how they make money. Installation, again, can be very simple. It could be throwing something in a box as you ship it and scanning a barcode, or it could be creating a custom mount, having to train someone to install that. And so that's very variable. I don't want to put a dollar figure on it, but you could think of it in terms of anywhere from near free to major disruptions in your business that can cost you, tens of dollars per thing that you're tracking. So just make sure you don't forget about that as you're thinking about your application. And during your proof of concept, you typically want to solve or at least have thought through how you're going to install things at scale. And then, as I mentioned, typically the way that we think about end of life or replacement is just doubling your installation cost. It's a very gross way of thinking about it. So if you have a really easy installation, again, you're throwing something in a box that's coming back to you. Your replacement cost is almost negligible. Changing out the battery might take you 30 seconds or a minute when you need to change out a battery. So there really isn't too much to worry about there. But if you have something mounted to a metal rack that's going to be out in the field for 6 months to 12 months at a time, and you only see it for 2 days as it comes back through your facility for refurb, you have to think really carefully about that life cycle. So what do we have to offer you today? Well, for this webinar only, we have launched a SuperTag evaluation kit, which includes 4 SuperTags, 4 indoor location beacons, so you can evaluate how microlocation works, and then you also get 3 months of connectivity and platform, as well as some professional services to help you get up to speed. And we would normally charge $750 for this, but we'll take 25% off if you order from this webinar. And so if you're interested in this, please either email us or in the chat window, send your email and your phone number, and we'll reach out to you with a code. We want to control this code because it is actually really quite a good deal. These evaluation kits are not something that we make money on anyway, and so this is sort of a discount beyond that. But we find that the best way to figure out whether this works for you is to just try it and compare it to other things that you've seen and to see how it's different. And then the next question we typically get is, well, how much does it cost for 100 or 1,000 or 100,000 of these things? The easiest way for me to answer that without understanding your specific use case and terms is our kind of low volume pricing is in the order of magnitude of around $60 for activation and $10 a month, and that includes everything. So everything you saw above: the hardware, the connectivity, the platform, for up to however many years your tag is designed to last. And then at high volume is going to be about half of that. But again, it's very use case specific and term specific, and so we like to make it really easy. Make a relatively low activation fee, and then a relatively low monthly fee as well that includes everything that you need. With that, final pitch for Link Labs. We'd like to think we have good support, ease of use of our products. We have an API if you don't want to use our fancy user interface and dashboard. We have field services to help you with installation. We have professional services that you can use that have a lot of experience in different types of environments and different types of technologies. And so we'll scale with you. We don't view these trackers as commodity devices. We view this application as very unique to what you're trying to solve. And so you'll find that our approach is very consultative. And if you're not getting that, feel free to reach out to me directly, and I'll talk to our sales team about making sure that you're getting what you need. So with that, turn it over to questions and answers, Jennifer.
All right, let's take a look at what questions that we have so far. So Glenn, where does this technology and the SuperTag work? Is it global or is it just here in the US?
Yeah, that's a good question. I haven't really gone into this that much, into this webinar, because we have another one that talks about this, but we use what's called LTE-M or LTE Cat M1 in this tag. That's a new type of technology. It's a few years old. As I mentioned, we had the first carrier certified device in the US with it. You can consider it a 5G technology because it is part of the 3GPP release 13 and above. And it's designed to take a very sort of narrow part of spectrum, so you can operate thousands of devices per base station at the same time as you're offering gigabit speed on that base station through other channels. And so it's very spectrally efficient. That technology is only available in about 40 countries now. So, our primary market is North America, and it is available pervasively in Canada, the US, and Mexico. We've tested it in a number of European countries. But what I would say there is if you have questions about a country outside of the US, please just send me a note and I'll tell you whether we've tested it or not there, or whether there's coverage there at all for LTE-M. There's another technology called NB-IoT, and that covers another about 50 to 100 countries. That's a little bit different. We don't like to use that if we can avoid it, because there are some issues with roaming and firmware updates with NB-IoT. But it's available in our hardware. We just typically don't deploy software that supports it. But if you're in a country that only has NB-IoT, please, again, reach out and we'll talk about what's available for you.
And how long can I expect the tag to last?
Another good question. You guys have a lot of good questions today. So the tag's life is really a function of three things. One is the frequency in which you take a fix or you do a location scan. So, and the technology that you're using for that location scan. So if you're doing GPS all the time, your tag is gonna not last as long, and especially if your GPS is failing. So for example, with a smaller tag, with the SuperTag Pro, you might expect about 500 fixes if you are doing GPS and you're failing GPS every time. If you are doing GPS and you're succeeding and it's a good fix, you might expect something like anywhere between 1,000 and 2,000 fixes in that case. And if you're doing something like Wi-Fi, and you might get something around 4,000 to 5,000 fixes. So again, it can vary very much by the frequency of location update as well as the technology you're using. The other thing that matters is the sleep current. We have very, very low sleep current, and so in most use cases it doesn't matter that much, but that starts to matter as you start to go longer in years. And so once you're at year 3, 4, 5 with the smaller tag, and sort of 6, 7, 8 and on with the larger tag, sleep current matters a lot in those cases. But like I said, we have a really low sleep current. It's power optimized to not be doing anything when you're not doing a location fix, and so we think we've addressed that issue. And then the other is really just an easy one. It's battery size. So are you using a 2,000 milliamp hour battery, or 4,000, or an 8,000? And there's the two devices we have are 2,000 and 9,000 respectively. There is some derate that happens over time, and then there's the capacity of the battery chemistry, and so we use special lithium metal batteries that can last a very long time and have very low self-discharge. But battery is really important when you start thinking about very long lived applications. So I don't know if I answered that question exactly, but for the SuperTag Pro, most of our use cases are anywhere between 1 and 3 years, and for the large one, it's anywhere between 5 and 8.
Here's another one. Do you support EDRX mode, and how much power does that use for a interval?
So EDRX mode is it's enhanced disconnected receive mode. And it's unique to LTE-M and NB-IoT. I'm not going to get super deep into the weeds of EDRX and PSM mode. There's another webinar that I have that has that. The only reason you would use EDRX is for an asset that was always on and you wanted to reduce the overall power consumption or prolong the battery life. We don't use it because our devices are almost always off. And so and actually what we found with our devices, PSM mode really doesn't help us that much either. And so think of EDRX as, so your cell phone has DRX. When it's connected to the network and it's going back and forth and sending data, when it's not sending data, it tries to go to sleep, but then it goes up and down, it spikes up and down as it's doing signaling between the base station and your phone. With DRX mode, you can prolong your phone battery maybe 20% or 30% or 40% over, the traditional fully connected modes. With EDRX, you might be able to prolong an additional, 20, 30% over just traditional DRX, maybe even a little bit longer depending on your use case. But you're not going to make it last for, 5 years, right? It's basically it's an alternative to always on. PSM mode is interesting because it sort of does the thing that we do manually. With PSM mode, if you're using that mode, the network and the device are making the device sleep between paging cycles. And so what it's doing is it is simulating kind of shutting off and going into a deep sleep mode between paging cycles. But what we found with PSM mode, if you're in PSM mode and you're transmitting less than around, 4 to 6 times a day, it's better just to shut the modem completely off and just to isolate power to it, because you're draining more with just keeping that device in PSM mode. And so if you're in a use case where you're sending once an hour, once every 10 minutes, PSM mode can be very valuable. Again, most of our use cases aren't doing that. That's not where we see ourselves offering a lot of value. So while we are very familiar with PSM mode, we don't support it either in our standard offering. But again, all things are possible. We're very familiar with all these things, and for the right use case, we can make changes as necessary to what we do.
What is the highest frequency update rate?
So we recommend not doing any more than a 5-minute update rate with GPS, because we time out our GPS at 3 minutes. Again, this is configurable, so we don't have to do that. But for our benchmark, we find a good balance of yield in GPS is around 3 minutes. So that's a very long compared to others. But what we found is basically you're either going to get GPS within 3 minutes or you're not going to get GPS at all. And so we don't leave it on past that. We've seen other applications time out around 90 seconds. We find that for some of our applications where you might have weak GPS, but not necessarily no GPS, 90 seconds is not enough to get you that fix, and you end up wasting a lot of battery but not getting a lot of fix. And so again, this is something that we can look at in your use case during a proof of concept. We can do a 1-month report where we say, hey, in your use case, after a month, here's all the times your device used GPS, here are all the times it used Wi-Fi, here's how many seconds on average your device is spent scanning for GPS. So these sorts of things can help you tune the device to suit your needs and to maximize battery life, but also while yielding the best results in terms of fixes. And so the reason we use 5 minutes is really just to account for that. If you were doing, a cell ID scan or a Wi-Fi scan, then, of course you can increase the fix interval to every minute or every 30 seconds. But frankly, like our device is no different than any other device if you're doing that. So, while we think our device is affordable, we're not using all the cool bells and whistles that you might see, or that you might see if you're using some of our other features in the longer-lived applications.
Cody is asking if there are plans to support ultra-wideband with the tags.
So I never say never. We have looked at ultra-wideband. We like it. We especially like now that the cost of the ultra-wideband chips are coming down significantly, because Apple and Samsung and everyone now is starting to put UWB in their phones. So the short answer is we're considering it. One of the nice things, though, is that we can get ultra wideband level accuracy with the Bluetooth 5 chip with some of the things that we're working on. I'm not going to spill the beans on that yet because it's not a released product. But one of the things about the new Bluetooth spec is there are things you can do with Bluetooth ranging to get you kind of sub-meter level accuracy. Now, it might not give you quite centimeter level accuracy like some ultra wideband does, but you could do it in a chip that costs $1 or $2, which is, even as ultra wideband chips come down in price, they're not quite going to get that low. And then also you can do it with a lot less power with the way that we think about the Bluetooth chip ranging. So stay tuned for more on that. We'll definitely do a webinar on that sometime in the next couple of months. So right now, the answer is no, we're not supporting ultra wideband on our devices because we are going to look to implement this Bluetooth technology first. But of course, if the market dictates that ultra wideband is a requirement, then we'll do it because that's what we do.
Is there a way to know that the signal is not being spoofed on expensive assets so that you know the unique identity of the tracker?
Yeah, it's funny that this question comes from a few specific countries typically. So if the questioner is from Brazil, it's a question that we've heard a lot. So the short answer is there are a lot of things that we can do to mitigate spoofing. One of the nice things, again, because our device is not always connected, you basically have to catch a device when it's transmitting to be able to intercept a signal. And then you also, I think most of the devices that you would use to spoof cell signals now haven't really caught up to MB and LTE-M. So I think you future-proofed it a little bit. You know, I can't say that it's impossible. All things are possible. There are technologies out there. You know, it's obviously illegal to do that. So in a lot of places, you can't even buy these types of devices. You know, so the short answer is we think that we are pretty good around spoofing, but we're not doing anything that is unique to Link Labs. We just think that the LTE-M technology and NB-IoT is less susceptible to spoofing than other things. Now, there's other things that we can do on the back end around data analytics, right? So if we know a device is supposed to check in, you know, with X periodicity, and that stops, then all of a sudden it's happening a lot more, or whatever. You know, that's a different story. But yeah, I think it's not a problem we've experienced, but we know it's out there.
What's the voltage of the battery, and how long would it last on a 5-minute GPS fix?
So the voltage, it's a 3.6 volt battery. It's either a lithium thionyl chloride or a lithium manganese oxide battery. So like I said, it's a lithium metal battery. So the battery is a little bit more expensive than your off-the-shelf Duracell, or even more expensive than a typical lithium-ion battery. With a 5-minute GPS fix, so again, anywhere between 500 and say around 2,000 fixes, depending on your GPS coverage. So I'm not, my mental gymnastics are not as up to date. So that's, so at 5 minutes, you're talking 12 fixes an hour. So 500 divided by 12, so, you know, 50 hours, between 50 and 200 hours. So a couple days to a couple weeks. So not that long. But you know, what I would say is
mine on a cross-country trip, and it was about 90 days on the 5 minutes. So
yeah, but you also weren't moving all the time.
Yeah.
Right. So that's also where. So with an accelerometer, we don't send a fix if you're not moving. And so if you're constantly moving, it will only go, you know, for the number of fixes. But in that 90 days, Jennifer, you probably got, you know, around 1,500 fixes. But because you slept, I think, and you probably
a little bit. Sounds good. All right. Well, we are right at the top of the hour. We are happy to answer any additional questions that people have. Feel free to reach out to us. Feel free to reach out if you'd like that coupon code. You can do that in the chat now, or you can respond to the email. We'll have a link where you can get that that comes out in the next 24 hours or so. In the meantime, feel free to reach out to us if you have any additional questions. But we appreciate everybody who's been on board, and thanks for spending this hour with us. And thanks, Glenn.
Thank you. Thank you.